Today I want to demonstrate my Robotis Bioloid CM5 Bluetooth modification. I'm going to go ahead and jump right into it. I'll turn on the CM5. I'll start up a robot terminal. I've modified the colors to make it easier to see on this video. I go ahead and hit start on the CM5. And as you can see, we're getting a response at the robot terminal. I can issue commands. As you can see, while I'm typing, the serial LEDs are responding. I'll go ahead and have it move the Dynamixel to position 200. Hit enter and it responds. I'm going to go ahead and set it back. And then I'm going to go ahead and turn it off so I can give you guys an inside look. One of the first things you'll notice is I've got this plug on the outside in the normal serial port. It's just a dummy plug. The purpose of it is to ground out a pin on the ATmega chip that's normally grounded out when a normal wired serial line is in place. That lets the firmware know that it's going to be interacting, with programming, that it's not just receiving commands like is usually done through the Zigbee. The Zigbee and the normal serial share a little bit of the same circuitry. Two of my goals in doing this setup were to make no modifications to the board itself, and also to try to avoid making modifications to the case. I've seen solutions implemented that used Blue Smurf wireless modem, and I've also seen it implemented with Pirani chips. The Pirani chips, they usually wind up having to make modifications to the board, cutting traces and making jumpers. And of course the Blue Smurf wireless modem is too big to fit inside the case. As you can see, I haven't made any modifications to the case. And I'll go ahead and open it up. And there you can see the chip that I'm using for the Bluetooth communication. It's a Roving Networks RN41 Firefly chip. It's the same chip that's I believe that's used in the Blue Smurf modems, but this is a standalone surface mount device. I connected it to the board using a recycled IDE cable. The wiring is 30 AWG solid strand wire, and I used a magnifying glass and a fine tip soldering pen to make the fine connections to the pads. I've got regular electrical tape protecting it because I just have it free floating inside the case. To make the fine solder connections, I used liquid electrical tape that actually works pretty well as a glue to glue the wire in place while I was soldering it. Another thing you'll notice on the board is that there are three 10 kilo ohm resistors wired in series from the TX pin of the Zigbee port to the ground. I'm using those as a voltage divider. I have the RX of the chip connected after the first resistor, while the power coming from the Zigbee port on the CM5 is 3.2 volt. The logic for the serial communication on the board is 5 volt, and the Firefly chip is all 3.2 volt. So in order to protect it, I've got it wired through this voltage divider. A nice thing about this 30 AWG wiring is it's so thin it can actually pass through the holes where the Zigbee chip's header pins would normally get soldered to. And I've got the TX from the chip running through the hole to the back side of the board and connecting to the RX pin on the Max 202 chip. Like this, I'm able to use this as a fully functional wireless Bluetooth replacement for the normal serial cable. And through all my testing, it seems to completely work. There are some caveats which I'll touch on in a later video around using the behavior control programmer and the motion editor. But otherwise, with just a little adjustment to the way you do the normal programming, this Bluetooth wireless serial connection is a fully functional replacement for the normal serial line. Well, thanks for watching.